Okay, over to chemical analysis, and we're looking at question 1, chromatography. It says, why did this person use a pencil? So you have to explain why they used a pencil. Now, people said various things, but the key words I think you needed to get in was so it doesn't smudge, it doesn't run, and it doesn't dissolve. So those are the key words, okay? Because if you have to do it in pencil otherwise, to avoid these things happening. Describe what would happen if the solvent level is above the start. So that's a bit like saying if this is your beaker and this is your filter paper and and this is your pencil line, but the water, the solvents come to about there. So now your ink is fully submerged in the solvent. What would happen? Well, the ink would fully dissolve into the water. So the ink would dissolve into the solvent. So it wouldn't even move up the paper because it would go into here, and this colour of the water might even change as well if it's coloured ink. Use the chromatogram to draw conclusions about the colourings in drinks X and Y. So I would just circle what I'm trying to look at, and now it's about coming up with as many conclusions as you can. You can talk about how many different dyes they've each got, because you're kind of making conclusions, so you're kind of comparing as well. So you could talk about how many dyes they've each got. You could talk about which one X has that Y doesn't. You could even talk about which of these A, B, C, D is in each of these. So what you end up with then are some possible points. So for instance on here, you could have said X contains 6, Y contains 5 colourings. All they've done is they've added them up. Okay? You could have said both X and Y contain the same 5 colourings. So 5 of these are the same as the 5 in there. That was another mark. Both contain A and C, neither of them contain B or D. So you're looking for really comparing similarities and differences as part of your conclusions. Use the chromatogram to draw conclusions about the colourings. Sorry, we've done that one. Okay, 1.4. Which artificial colouring has an RF value of 0.3? And the answer to that was actually A. And I guess, how would you work that out? So you'd have to figure out, they've given you some relative distances here. So if that was 10, you can't see clearly on the video, but they've got your numbers. So you'd have to do the division. You'd have to say, right, I know that RF is the distance of the spot divided by the distance of the solvent. And then you're going to have to do some quick calculations, process of elimination, do it for each one until you find one that gives you 0.3. So you're kind of working backwards. But the answer for that was actually A. Are soft drinks X and Y pure? Well, if they were pure, would they have lots of dyes in them? So the answer is no. And the reason is the drinks contain more than one compound or substance or mixtures or contain various colourings. So anything like that, that indicates it's a mixture. Okay.